So for this example, we are going to be solving systems of linear equations. And a system of linear equations is a group of linear equations that work together to solve problems. A system is identified by a large curly brace, as you can see them right here for each one of these problems. It's a large curly brace. And this brace encloses the equations. And to solve a system means to determine the point of intersection that satisfies all the equations of the system. This is very similar to what we just did in the previous example, except this time the equations are now labeled as a system. Also, notice that as we write a system, we tend to line up the variables and the operators in these nice, neat columns like this. Not only is this good for clarity, but later we use this approach when we start to build matrices. So for letter A here, in order to solve this, I'm going to rewrite these equations in slope-intercept form. Right now they are in standard form, but similar to what we did before, we put them in slope-intercept form. So I'm just going to put in a curly brace here. And then I'm going to rewrite each one of these equations in slope-intercept form. So here I have 2x minus 3y. That's equal to negative 3. That's our first equation. We'll solve for y. That'll be negative 3y. That's equal to negative 2x minus 3. Divide everything by negative 3. Y is going to be equal to 2/3 x plus 1. So I'm going to rewrite this first equation in slope-intercept form, which is y is equal to 2/3 x plus 1. I'll do the same for this equation here. X minus 4y, that's equal to 1. Solving for y, we have negative 4y. That's going to be equal to negative x plus 1. Divide everything by negative 4. Y is going to be equal to 1/4 x minus 1/4. So we have y is equal to 1/4 x minus 1/4. So here I went ahead and I transferred or changed these into slope-intercept form. And of course, as we did in the last section, in order to be able to solve this, we now make each one of these equations equal to each other and then solve for x. So we'll do that. So here I'll take 2/3 x plus 1, and I'll make that equal to 1/4 x minus 1/4. I could then subtract 1/4 x from either side and subtract 1 from either side. This will give us negative 1/4 x plus 2/3 x. That's going to be equal to negative 1/4 minus 1. Negative 1/4 x plus 2/3 x. That's 5/12 x. And negative 1/4 minus 1 is negative 5/4. So then to solve for x, I can multiply the entire equation here by the reciprocal of 5/12, which of course is 12/5. The idea is 12/5 times 5/12. These will cancel each other. So 12/5 times 5/12, we're left with x. 12/5 times negative 5/4 is negative 3. So here I'm just going to write down x is equal to negative 3. We can then take this negative 3 and slug it into either one of these equations here and then solve for y. So how about if we choose the first one here? Y is equal to 2/3 x, and x is negative 3 plus 1. Y is equal to 2/3 times negative 3. That's negative 6/3, which is negative 2, plus 1. And of course, negative 2 plus 1 is negative 1. So then I'm just going to write up here, y is equal to negative 1. At this point, when we're solving systems, there really is no need to have to write this as a coordinate because they are going to represent items. So we're just going to say for now, x is equal to negative 3 and y is equal to negative 1. But we'll do the same for b. So I'll put in my little curly brace here, and I'm going to rewrite these in slope-intercept form. 5x minus y, that's equal to 80. Negative y is going to be equal to negative 5x plus 80. We divide everything by negative 1. Y is going to be equal to 5x minus 80. So here we go right here. Y is equal to 5x minus 80. Now here we just have x is equal to 22. So this makes a vertical line, but I'm just going to leave that as x is equal to 22. But now since we know x is equal to 22, we just simply slip it in right here. So this is going to give us y is equal to 5 times 22 minus 80. Y is equal to 5 times 22 is 110 minus 80. 110 minus 80 is y is equal to 30. So here we have x is equal to 22 and y is equal to 30. So again, at this point, there's no need to have to write this as a coordinate. We can just go ahead and leave it at this because these are going to start representing items. And finally for c, I'll put in my curly brace and rewrite these in slope-intercept form. 3x plus 5y, that's equal to 9. We solve for y, we have 5y. That's equal to negative 3x plus 9. Divide everything by 5. Y is equal to negative 3/5 x plus 9/5. So now I rewrite this as y is equal to negative 3/5 x plus 9/5. Do the same for the second equation. 2x minus 2y, that's equal to negative 9. Solving for y, negative 2y, that's equal to negative 2x minus 9. Divide everything by negative 2. Y is going to be equal to x plus 9/2. So y is equal to x plus 9/2. So now in order to solve, we'll go ahead and we'll make these equal to each other. So we'll take negative 3/5 x plus 9/5. Make that equal to x plus 9/2. Subtract x from either side and then subtract 9/5 from either side. We'll have negative x minus 3/5 x. That will be equal to 9/2 minus 9/5. Negative x minus 3/5 x is negative 8/5 x. And 9/2 minus 9/5 is 27/10. We can then multiply the entire equation by the reciprocal here. That'll be negative 5/8. Negative 5/8 times negative 8/5, we're left with x. And negative 5/8 times 27/10 is negative 27/16. So x is equal to negative 27/16. 16ths. We now take this and slug this into one of these equations. It doesn't matter which one, but we'll slug it into this one here. It seems simpler. So that'll give us y. That's going to be equal to negative 27/16. That's our x. Plus 9/2. Negative 27/16 plus 9/2. That's going to be y is equal to 45/16. So then y is 45/16. And we can certainly check to see if these are the actual values by going ahead and slugging them in. We'll just kind of visually see what's going on here. If x is -3, then 2 times -3, that's a -6. And if y is -1, then -3 times -1, that's 3. So -6 plus 3 is equal to -3. If we do the same here, if x is -3, we have -3 plus 4, -3 plus 4, because if y is -1, -3 plus 4 does equal to 1. So we can go ahead and we could check them, and they should all work. But other than that, there we go.